increasing the size of an existing warehouse, and we do this to handle performance issues that are related to more complex queries. So this is something that can be beneficial. However, scaling up might not help with more basic queries or in general performance issues that are caused by a large number of concurrent users or concurrent queries. And in this case, it is scaling out that can be more beneficial. So scaling out involves adding additional warehouses, and usually this is done by adding additional clusters to our multi-cluster warehouse. So we use a multi-cluster warehouse for scaling out, and this helps us now to handle performance issues that are related to a large number of concurrent users or queries. An additional benefit is that they also dynamically automate this process of adjusting to these changes in user numbers, which is of course something that can be very common in an organization, that we have, for example, certain times in a day where we have more users checking in maybe on some reports or some queries. So therefore we can also automate this to adjust the capacity that is needed. So that's a very important feature in Snowflake. So if we want to do this, we have to just keep in mind that this is more related to the number of concurrent users, and also the second benefit, we can kind of automate this process, and this makes it very dynamic to adjust the capacity depending on the workload. So let's briefly recap how this works. So we have, of course, the two different types of scaling policies. We have the standard and then the economy, and depending on which one we are using, additional warehouses or additional clusters in our multi-cluster warehouse will be spinned up in different times. So usually this is just when there are more queries that can be processed by the currently available clusters, then just an additional cluster will be spinned up. And depending on the type of scaling policy that we are using, this can be a little bit more towards better performance, which means we would earlier spin up additional clusters, or it can be also, if we use economy, a little bit later. So it will be just a little bit more conservative with spinning up additional clusters to save a little bit more cost. So this is in some way this auto scaling feature, basically depending on the workload, to do this very dynamically. So this is something that we should now also consider, that of course, first of all, this is an enterprise feature. So we can use this starting from the enterprise edition. And if we use the enterprise edition or a higher version, then we should have actually per default, this is a best practice, all of our warehouses be multi-cluster warehouses, because essentially we don't really have a downside to using a multi-cluster warehouse unless we have some very, very specific reason. But in general, it is actually just recommended to use this multi-cluster warehouse per default. And of course, the default should be one. So like this, we can save cost and we don't need to have additional unnecessary warehouses when we don't need them, or additional unnecessary clusters. And the maximum can be actually pretty high. So here we don't need to put it to a very low number to save cost, because it does not make a difference if we, for example, have 2 clusters in our warehouse that take 1 hour, or then in the other case, if we have 4 clusters in our warehouse and they only take half the time. So this is how it usually plays out with those multi-cluster warehouses. So this means that if we have the necessity to use 4 clusters and they will be automatically spinned up, this would essentially cost us the same, because it will be usually double as fast with the current workload, because if we would use only half of them, it would most likely take the double amount of time. So this is because we have more users, more queries, and this is how it plays out then with this multi-cluster warehouses. So in this case, we can have this maximum set to a relatively high number. We don't need to limit this unnecessarily. So this is just a best practice that I wanted to mention. And now let's briefly also, of course, jump into our Snowflake account to see this in practice. So in my Snowflake account, I will now use this rather complex query that takes a little bit of time. And because we are using here some cross joins and they are usually, quite, computational intensive. So therefore I will use this, and let's have a look also at this first warehouse. This is a multi-cluster warehouse and we want to use this one. So therefore let's go into projects. We have created this before. If you haven't, you can just under the warehouses in the admin section also set up a new warehouse and just use here under advanced options these additional clusters in the multi-cluster warehouse. So you can set it to 3 and you can just leave the scaling policy also at standard. So in our case, we will just go into our worksheet and here we will now set up multiple times these queries. So this means I will use one worksheet for this query, then I will just set up a new worksheet and I will use the same. So like this I can simulate multiple users, and like this we can hopefully bring this additional warehouse to the situation that it will automatically scale out, so it will spin up additional clusters in our multi-cluster warehouse. So let me maybe set up something like 7 or something like this, and then hopefully we can use the multi-cluster warehouse and we can bring it to scale out. So let's just go ahead and execute it. But of course we want to use our first warehouse. This is our multi-cluster warehouse, and I will execute this query. Afterwards I will also select this one and execute also this query, and I will now execute all of those queries. So now all of those queries are running, and you can see this takes a little bit of time, which is nice because like this we can simulate that there are additional queries that need to be processed. And if we now have a look into our admin section under the warehouses, we can see, let's maybe refresh, here currently one cluster is active. So probably we have here 6 running queries, and now if we add maybe 2 more queries, so here we should see currently nothing is queued, so we want to queue this. So therefore we want to make this a little bit more, we want to use more queries. So let's try this. I will also execute this one and then maybe one more. Also execute this one. And now if we have a look into our warehouses again, I will see that after a little bit of time, this additional warehouses, after I have refreshed, will be spinned up, because now I have 9 queries running, and actually I also unfortunately run one on this one by accident. But here we can see that now there are 2 clusters active, because we have in this case 9 running queries. And of course in this case it is even not necessary to have something in queue, because we remember this will be automatically already spinned up when we anticipate that there's more than currently can be processed. So there doesn't need to be even 1 second where something needs to be queued for this to be spinned up under the current policy. But of course, now we have also 2 running, so hopefully there is nothing in queue, because otherwise there should be an additional cluster spinned up. Alright, so this is how we can use the multi-cluster warehouses. And now I will also of course suspend this again. So in this case we don't need it, so therefore let's save some cost and let's get this suspended, as well as also this compute warehouse. And since those queries will still be completed and they might take very long time, we also want to abort this, so this would just save us a little bit of time. So in this case I can just cancel all of those queries, because they are designed so that they are running for a very long time. So therefore I will just manually cancel them, and if you want you can do so as well. So I'm just canceling all of the queries, and if I now see that there is still one running query that I might have missed, I can just click on this, and in here under this warehouse I can then see all of the queries that are running and that are failed, and I see these are a lot. So I can just also filter it by the status, and if I say running, I will see the remaining one that I have missed, where I can also now just cancel this query by clicking on this X and then saying cancel query. And like this we see that now we have all of the queries cancelled, and now this warehouse can shut down. So I hope this was helpful in demonstrating how we can use scaling out using related to caching. So caching is an automatically enabled process that is designed to speed up the execution of query results by using the results from the cache. So basically the results are stored. We don't need to reprocess the query again, but we will just use the results of the queries again that are stored in cache. So let's briefly talk about how this works and then how we can benefit from it. So what we can do. So let's first talk about how caching works. First of all, this is an automated process, and this works in the way that when a query is executed, the result is cached. So this means it is stored, and like this it can be reused later. Cached results are of course not stored indefinitely, but they are cached for 24 hours or until the underlying data changes. So of course, if the table, some data is changing there, then the result cannot be reused, but it will just execute the query again from fresh. So like this, we can make sure that we always get, of course, accurate results and that we don't get some wrong results from this process. So Snowflake here is very efficient actually in understanding the metadata. So like this is it is ensured that the cached results are used only when they are actually valid. So if the underlying data is changing, then Snowflake knows that we need to re-execute the query rather than using this outdated cache, which is not correct anymore. And also we have mentioned that caching is automatically managed by Snowflake. So this means that we don't have to bother with it. And this is just simplified for us. But since this is automated, we might wonder, what can we actually do in regards to optimize this? So what is our job here? So again, while users can't control the cache directly, we can ensure that similar queries run on the same warehouse, because the cache results work depending on the warehouse. So this is for each of the warehouses, and then if a similar query is run again on the same warehouse, then we can like this maximize the cache. And this brings us back to again using dedicated warehouses for specific or dedicated workloads. For example, if we have a team of data scientists, they might run similar queries because they have maybe similar users, similar use cases, they work on similar data and so on, then they should all use ideally this same warehouse, and like this they can maximize the benefits of caching. So this is what we need to keep in mind, that we should ensure that similar queries are directed to the same warehouse so that we can take the most benefit of these cached results. And this helps to improve the performance by reducing the need to re-execute identical or very similar queries. So caching in Snowflake is an automated process, but it can improve the performance. And what we can do is we can try to maximize this by ensuring that we run similar queries on the same warehouse. All right, so now let's put this theory into practice and see how this works in action.